Mars, the red planet. Perhaps the most fascinating and mysterious body in our solar system, after Earth, of course. For centuries, humans have gazed up at the sky and wondered, what if we could live there one day? With its barren and desolate surface, Mars seems like the perfect setting for an apocalyptic scene. But there's so much more hiding beneath that dusty exterior. Its name, Mars, evokes images of war and mythology, but it also sparks visions of exploration, innovation, and maybe even hope. After all, what do we really know about Mars? And more importantly, what's still waiting to be discovered? Our journey to Mars is a constant quest to unlock its secrets. Scientists and engineers have devoted their lives to understanding this world, a planet that feels distant yet may hold the key to humanity's future. What happened to Mars? How has it evolved over billions of years? Could we one day walk its surface? Or even call it home? Let's explore it all, from Mars's fiery birth to its ancient landscapes to humanity's dream of colonizing the red planet. Get ready for a journey full of discoveries. Together, we'll uncover the story of Mars, a story that's still being written. To understand Mars today, we have to go back, way back. Over 4.5 billion years ago, our solar system was just a chaotic cloud of dust and gas, spinning around a young, furious sun. Tiny particles collided, stuck together, and gradually built the planets we know today. Mars formed out of this cosmic chaos. But unlike Earth and Venus, which grew into massive dynamic worlds, Mars's story took a different path early on. It's smaller, only about half the size of Earth, and lighter, too. This meant it couldn't hold on to the same thick, protective atmosphere that Earth developed. Right from the start, Mars was destined to be different, a world that would cool quickly and live a quieter life. Its core, once molten and active, began to solidify much faster than Earth's. Without a powerful magnetic field to shield it, solar winds from the sun slowly stripped Mars's early atmosphere away. Bit by bit, the red planet lost its ability to retain warmth, moisture, and, possibly, life. But during those first few 100 million years, Mars was a completely different world. Massive volcanoes erupted, filling the skies with ash and gases. Ancient rivers carved valleys into the surface. It's even possible that large oceans once covered parts of Mars, shimmering under a young, bright sun. If we had visited Mars in those early days, we might have seen landscapes not too different from Earth's. Flowing rivers, cloudy skies, maybe even rain. Yet because Mars is smaller and colder, it couldn't hold on to that vibrant life for long. As its internal heat faded, its magnetic field collapsed, the atmosphere thinned, and surface water either froze into the soil or evaporated into space. In a cosmic blink of an eye, Mars transformed from a dynamic, possibly wet planet into the dry, dusty world we see today. It became frozen in time, a planet that never got the same second chance as Earth did. And that's what makes Mars so fascinating. It offers a glimpse of what could happen to any Earth-like planet if the conditions aren't just right. To understand Mars today, we have to go back, way back. Over 4.5 billion years ago, our solar system was just a chaotic cloud of dust and gas spinning around a young, furious sun. Tiny particles collided, stuck together, and gradually built the planets we know today. Mars formed out of this cosmic chaos. But unlike Earth and Venus, which grew into massive dynamic worlds, Mars's story took a different path early on. It's smaller, only about half the size of Earth, and lighter, too. This meant it couldn't hold on to the same thick, protective atmosphere that Earth developed. Right from the start, Mars was destined to be different, a world that would cool quickly and live a quieter life. Its core, once molten and active, began to solidify much faster than Earth's. Without a powerful magnetic field to shield it, solar winds from the sun slowly stripped Mars's early atmosphere away. Bit by bit, the red planet lost its ability to retain warmth, moisture, and, possibly, life. But during those first few 100 million years, Mars was a completely different world. Massive volcanoes erupted, filling the skies with ash and gases. Ancient rivers carved valleys into the surface. It's even possible that large oceans once covered parts of Mars, shimmering under a young, bright sun. If we had visited Mars in those early days, we might have seen landscapes not too different from Earth's. Flowing rivers, cloudy skies, maybe even rain. Yet, because Mars is smaller and colder, it couldn't hold on to that vibrant life for long. As its internal heat faded, its magnetic field collapsed, the atmosphere thinned, and surface water either froze into the soil or evaporated into space. In a cosmic blink of an eye, Mars transformed from a dynamic, possibly wet planet into the dry, dusty world we see today. It became frozen in time, a planet that never got the same second chance as Earth did. And that's what makes Mars so fascinating. It offers a glimpse of what could happen to any Earth-like planet if the conditions aren't just right. When we talk about climate, Mars is a world of extremes. There's no middle ground. It's freezing cold, colossal dust storms, and an atmosphere so thin it couldn't even fill a balloon. Mars is essentially a frozen desert. Average temperatures hover around 60 degrees C, 80 degrees F, but at the poles during winter they can plummet to 125 degrees C, 195 degrees F. On the warmest days near the equator, it can barely reach 20 degrees C, 68 degrees. But that's rare and highly localized. Its extremely thin atmosphere, less than 1% the density of Earth's, is made up almost entirely of carbon dioxide, 95%. Without a thick blanket of gases, Mars can't hold on to heat. As soon as the sun sets, the temperature drops rapidly. Despite the thin air, Mars has strong winds. These winds, combined with the fine dust covering the surface, create the famous global dust storms. They often start as local events and within days can engulf the entire planet, lasting for weeks or even months. In 2018, one of these storms brought the Opportunity rover's mission to an end after 15 years of operation. Martian dust is incredibly fine, almost like talcum powder. It blocks sunlight and complicates the operation of exploration equipment. Besides the global storms, there are also the so-called dust devils, swirling columns of dust, some reaching hundreds of meters tall, that roam across the landscape. Many rovers have captured them in action. Despite the dry environment, Mars has clouds. They form from crystals of water or carbon dioxide, especially in high altitudes and near the poles. Sometimes, they create stunning displays, like the famous blue sunsets, caused by how the dust and atmosphere scatter sunlight. Mars also experiences seasons, just like Earth, because of its tilted axis. But since Mars is farther from the Sun, each season lasts nearly twice as long. A Martian year is about 687 Earth days. During polar winters, something remarkable happens. Carbon dioxide in the atmosphere freezes directly onto the surface, forming seasonal polar caps. And when it gets even colder, carbon dioxide snow falls, flakes of frozen CO2 gently drifting down under the red sky. Despite all this atmospheric activity, Mars remains extremely dry. Even where ice exists, liquid water is unstable. It evaporates or freezes almost instantly. Today, Mars is cold, dry, and battered by storms. But billions of years ago, it was a different story. Rivers, lakes, maybe even oceans. A past we'll dive into later. For now, it's clear. Mars' brutal climate, with its extreme cold, violent storms, and thin air, stands as one of the greatest challenges for future human explorers. Any colonization plan will have to survive under its dusty skies. Today, Mars is a cold, dry desert, but billions of years ago, its story was very different. Imagine a world where rivers flowed freely, shallow seas stretched across vast plains, and a mild climate made life not just possible, but perhaps likely. Strong evidence suggests that between 3.5 and 4 billion years ago, Mars had a much thicker atmosphere than it does today. This dense atmosphere allowed liquid water to exist on the surface, forming extensive river systems, lakes, and possibly even oceans. Atmospheric pressure was hundreds of times higher than it is now, and global temperatures were significantly warmer. Traces of this ancient world are still scattered across Mars. Valley networks like those found near Valles Marineris and the dry riverbeds crisscrossing the surface tell the story of a planet once shaped by flowing water. Moreover, orbital missions have detected clay minerals, evidence that liquid water not only flowed, but chemically interacted with Martian rocks in Tucker. Places like Gale Crater and Jezero Crater, NASA's Curiosity and Perseverance rovers have found fossilized river deltas and ancient lake sediments. These structures preserve detailed geological records, suggesting that early Mars was an environment capable of supporting microbial life. But what happened to this promising world? Scientists believe Mars once had a strong magnetic field, shielding it from solar radiation. Around 4 billion years ago, that magnetic field collapsed. Without protection, the solar wind began stripping away the atmosphere, molecule by molecule. As the air thinned, Mars lost its ability to hold on to heat, and surface water began to freeze or evaporate into space. Oceans dried up, rivers disappeared. Mars gradually transformed into the cold, lifeless desert we see today. Small traces of water survive, trapped as ice beneath the surface or floating as vapor in the thin atmosphere. But the days of warm, wet Mars are long gone. Some theories propose that Mars experienced temporary periods of volcanic activity even after losing its magnetic field. These eruptions might have released greenhouse gases, causing short-term spring-like periods before the planet fell back into deeper freezes. Data from NASA's MAVEN mission shows that the loss of atmosphere was not sudden, but a gradual process that took hundreds of millions of years. During that time, Mars may have cycled between warmer and colder eras, enough time, perhaps, for life to gain a fragile foothold. In recent years, particularly from 2022 to 2024, new findings have reignited the debate about ancient life on Mars. The Perseverance rover, exploring Jezero Crater, an ancient lake bed, has detected complex organic molecules embedded in the rocks. These molecules are carbon-based, the fundamental building blocks of life. While organic molecules can be formed through non-biological processes, their specific distribution and concentration suggest they may have been preserved in an environment once habitable for microbes. Even more compelling, Perseverance found signs of potential biosignatures, chemical patterns in the rocks that on Earth are typically associated with biological activity. In parallel, instruments aboard the Mars Sample Return mission, set for launch in the late 2020s, are being designed to bring back Martian soil and rock to Earth, where scientists can study them with much more precision. If we find preserved microfossils, it could confirm that Mars not only could have supported life, it did. Meanwhile, methane detections in the Martian atmosphere, though still not fully understood, continue to intrigue scientists. On Earth, a large portion of methane comes from biological sources. Although geology can also produce methane, the presence of seasonal methane plumes on Mars suggests that an unknown, possibly active process is at work even today. Together, these findings don't yet prove Mars was inhabited, but they make the possibility more realistic than ever before. The image of ancient Mars that emerges is no longer just that of a wet planet, but possibly a living planet, at least for a while. And if life once existed on Mars, it raises a bigger question. Was life on Earth truly unique, or are we just one chapter in a far greater cosmic story? If Mars looks like a dead desert on the surface, it's underneath where things get truly interesting. For years, scientists have suspected that Mars hides deep secrets, literally. Using ground-penetrating radar from orbiters like the Mars Reconnaissance Orbiter, we've been able to see beyond the red dust, and the data revealed something incredible. There are layers upon layers of ice buried beneath Mars's surface. In some places, the ice lies just a few meters down. In others, it forms entire buried glaciers, some the size of entire cities. This ice isn't just a relic of the past. It could be the key to survival on Mars. Water means life, not only for drinking, but for producing oxygen and even fuel. Future Martian colonies will likely depend heavily on this underground ice. But ice isn't the only thing hiding beneath Mars's surface. Another fascinating mystery is the presence of lava tubes. These structures are giant tunnels formed by ancient lava flows. When the surface of the lava cooled and hardened, the still-flowing molten rock beneath created enormous hollow channels. High-resolution images show entrances to lava tubes on Mars, some tens of meters wide. These lava tubes could be perfect natural shelters against the deadly radiation that bombards the Martian surface. Mars' atmosphere is so thin that solar and cosmic radiation passes right through. Living underground inside these tunnels could shield future settlers, or perhaps even protected some form of Martian life in the distant past. And speaking of life, researchers believe that if there is any life still clinging to existence on Mars, it would most likely be hidden underground. Protected environments, with traces of liquid water trapped between ice layers, could be the last refuge for hardy microorganisms. Future missions, like ESA's ExoMars project, are planning to drill into the soil to search for signs of life. These missions aim to go beyond the dried-out surface and explore these hidden worlds. At the end of the day, Mars is like a book with many sealed pages. Each layer we peel back could reveal not just the planet's past, but clues about the future of our own species. On Mars, the planet shines more brightly in the night sky than most stars. Because of its proximity to Earth and the way it reflects sunlight, Mars has often been mistaken for a special star throughout ancient history, inspiring myths about war, gods, and power across different civilizations. Mars also has two very unusual moons, Phobos and Deimos. Unlike Earth's round moon, they are small, irregular, and shaped more like giant space potatoes. Even more fascinating, Phobos is slowly spiraling inward toward Mars. In about 30 to 50 million years, it will either crash into the planet or break apart to form a spectacular ring around it. Studies suggest that these moons may actually be captured asteroids, pulled into Mars' orbit during the chaotic early days of the solar system. Another surprising fact is that the soil of Mars is toxic to most known life forms, including humans. It contains high concentrations of perchlorates, chemicals that would make growing crops extremely difficult without advanced treatment. Future Mars settlers will have to find ways to purify the soil before using it for agriculture. Mars isn't as geologically dead as it seems. In 2019, NASA's InSight lander confirmed the existence of Marsquakes, proving that the red planet still experiences internal seismic activity. These Marsquakes reveal that Mars retains some internal heat and energy, despite its cold, barren surface. Adding to the list of mysteries, hydrated salts have been detected in craters like Hale and Horowitz. Under certain conditions, these salts could allow temporary flows of liquid water to form on the surface, a rare and fragile phenomenon in today's Martian environment. Perhaps even more incredible is the fact that fragments of Mars have actually landed on Earth. Meteorites like ALH 84001 were blasted off the Martian surface by ancient asteroid impacts and traveled across space until finally falling onto our planet. By studying these meteorites, scientists have gained precious clues about Mars's geological and chemical history. And if you ever set foot on Mars, you would immediately feel the difference. Your weight would be dramatically reduced. Mars's gravity is only about 38% of Earth's, meaning someone who weighs 70 kilograms here would weigh just around 26 kilograms on Mars. That lighter feeling would be one of the first unforgettable sensations of standing on another world. Now that you know some of the most amazing secrets about Mars, it's impossible not to wonder, what else is still hidden there, just waiting to be discovered? If you enjoyed this journey across the red planet, don't forget to leave a like, subscribe to the channel, and hit the bell so you don't miss any new explorations. And tell me in the comments, do you think we'll still find life out there? See you on our next journey through the universe.